Alright, here we're going to do a example of a linear regression on our new TI Nspires. So let's get started, and we're going to do the one from class where we had some information on sandwiches and the total fat grams in their relation to the calories of the sandwich. And we'll see if there is any correlation between those two variables. So let's open up a spreadsheet to start, and we will label our first column. We'll want to be our X column. We'll say these are the fat grams, so we'll label that fat. Oops. No, I don't want that. Let's just go down to A1. Alright, so the fat, there was a column of I think 11 examples here, and so I'll just type those in. These came from a list that we had. So you type these values in here, and sometimes if we have the navigator going, then I will just send you these files to save on some tedious entering. The next column we will have would be our calorie column, so this will be the total calories in the sandwich. And so like a 9 grams of fat, we're looking at 260. 13 would be 320, and so on. So I'll just type these in here. Something I always like to do is just to double check that both lists have the same amount of elements in them, so they both have 11, and that's good, because if they didn't, then you would get an error that would say mismatch, and that would be that one of the lists has more items than the other. So here we have our data entered, and we're going to go and put a scatter plot in as a graph. So we're going to get a new document. So I'm going to go to Control, and then Document will give me a new page. There's more than one way to do this, but this is the way I do it. And we'll add a graph. So when we add this graph, we don't want to put a regular function in there. We want a scatter plot, which means we're going to pull from two sets of data. So we need to go to our data graph entry edit line. So in menu, I go to graph entry edit, and instead of function, I want scatter plot. And this is where I'll be able to pull from the two lists I just entered. So these are stored in the var button. So we go to var, and right in there we have calories and fat. We want fat for the X, and for the Y we want to go back to that var, and we want the calories. Now you have to hit enter here. I forgot to put enter, hit enter in class, and then nothing happens. So I'll go ahead and hit enter here, and then it graphed it. And I can't see anything. What's the deal? I can't see anything here. Well, it's because it's not zoomed into the right part of your window. So here we're from -10 to 10. Well, the data we entered was like in the 260, so I can't see that. So I need to go to menu, and we need to change the window. And if you go to zoom data, number 9, then you will be able to zoom in right where your data was, so that it automatically adjusts the window for you. So we're going from like 2.1 to 36, and all the way up to 623 on the Y. So now there's our scatter plot. This looks like it has a positive correlation just by glancing at it. And if you were going to sketch the line of best fit like you've done in previous classes when you were a little younger, you could probably sketch something in there that would have a positive correlation. So, but now we're going to actually calculate that line of best fit, and so we're going to do a regression. So let's go back to our 1-1 tab. To do this, you hit Control and then to the left. That'll allow you to go through the tabs. And for this, I want to run a regression on these two, so I'm going to go to Menu and Statistics. Stat calculations will bring you to number 3, linear regression. We'll use mx plus b because I think we're more familiar with that from slope-intercept form. Alright, my X list I wanted to be fat, so I'll just click on that and select fat grams. Y list will be calories. And then this is going to save the regression equation to F1, so that'll be important to remember for when we graph it. Hit OK, and you'll see here now that it has given us all of our regression information in this C and D column. So this is a regression equation, mx plus b. Here is a slope of that linear regression line, 11.73. The y-intercept, so this is a little bit silly, but if you had 0 grams of fat, you could expect 190 calories based on this regression. And then the important part that we were focusing on is the R value. This again tells you how strong your correlation is between those two variables. And this one, based on this small amount of data, seems to have a fairly strong positive correlation. It's almost 1, so this would be very strong. Remember the correlation coefficient. Values between -1 and 1. And so -1 would be perfect linear negative. It would be a perfect negative correlation. It would be exactly a straight line. +1 would be exactly a straight positive correlation. 0 would be none. It's completely spread out so that there's no correlation whatsoever. So let's go and put this on the graph. So we go back to our graph, Control click to the right, and that will bring us back to our graph. We want to bring up a graph entry line, and we want function this time. Now it automatically brings you to F2, but you don't want to type in a new function. You want to use the one that we just already stored in F1. So if I click up one time, it's going to bring me to F1, which automatically has that regression line stored in there. So once I come to this point, I'll just click enter, and it will graph that line on there. Voila. So there we go. No more sketching that, guessing your line of best fit. Now we can calculate it. Here is the equation for the line of best fit, and so now we can use this to make some predictions. So let's say we want to predict for the double galley buster 2-pound burger at the Anchor Bar in Superior, Wisconsin, which is a delicious place to get a burger if you're ever in that beautiful city of Superior. Sort of kidding. So here we go. Let's get a new page. Control, document, new page. Let's get a calculator page. And if we want to predict using that function F1, we'll just type in F1 parentheses. And let's say we want the double galley buster, the 2-pound burger at the Anchor Bar. I'm going to guess has 75 grams of fat. How many calories are in that burger based on this regression? Enter. There'll be about 1,000 pound, or 1,000 pound, maybe 1,000 pounds to the person who ate it. 1,000 calorie burger. So probably not the best thing for you. So that's it. That's how you can do a linear regression. And you have the graph of it. There's the line. There's your scatter plot. There's the equation. You're going to be asked to list your correlation coefficient, which means how confident are we that there was a correlation between those two variables. And this we'll be very confident. 0.97 is very close to 1. So that would be a very confident positive correlation. And then to predict, we just went and opened up another calculator page. So there you go. Hope that helps. And that's a wrap.